Hello judges, I am Zachary Dahl, proudly representing the Georgia FFA Association. Today I'm excited to share with you the details of my SAE for Agri-Science Research and Integrated Systems. In my first experiment, I tested the starch content in starchy and waxy potatoes using a Brix refractometer. I learned to calculate starch using a formula of carbohydrates minus fibers plus sugars. I found starchy potatoes have a 4 grams more average starch on average than the waxy potatoes. In my second project, I tested the sugar content in a smaller variety of starchy and waxy potatoes. I also used the Brix refractometer to measure the sugar and calculate the starch content. After completing the experiment, I learned that increased sugar decreases starch by 57%. Switching to power systems in my third experiment, I tested the inaccuracies of satellite imagery land measurements methods. Results showed a difference of 4.74%. I then manually measured land with a surveyor's measuring wheel and compared it to satellite measurements and found a difference of 6.19%. In my most recent experiment, I evaluated the sugar levels in sweet and Murasaki potatoes before and after a 2-week curing duration. I learned that curing potatoes could increase sugar of 50%. Question 1. Why did I select my SAE research? When I began my first SAE project, I knew I wanted to study the impact of waste food for farmers. I learned that farmers have to throw away millions of pounds of food because of simple defects. After learning this, I conducted more research to learn helpful ways on how to earn farmers extra money from waste food. I focused on potatoes, which can be used to make bioplastic materials and also contribute to 21 million pounds of waste food in the United States landfills. I concluded that potatoes could be used as a source starch material for bioplastics, eliminating waste and potentially bringing more revenue to farmers. Being able to solve agricultural problems in a variety of areas will benefit me in my career as an agricultural engineer. Question 2. What were the different challenges you saw between the different types of research, and how did you mitigate those challenges? I conducted projects in food and power systems. A common limitation was a lack of times, funds, and equipment that could be used on a larger scale project a professional researcher would conduct. I used statistical analysis to help me evaluate my data. In my third experiment, I evaluated the differences of Google Earth measurements and QPublic measurements. After all data was collected, I conducted a statistical analysis where I got a generated p-value of less than 0.00213. This means that my data is significantly different because of a critical value of less than 0.05. Addressing challenges using skills like statistical analysis has helped prepare me for my future career as an agricultural engineer. Question 3. Why is the research that you conducted important to farmers and other industry professionals? I focused on aiding farmers over my 4 years of research. For example, I recommended that farmers use satellite imaging measurement for only practical applications on the farm, like fence building. However, I'm most excited about my financial impacts I found for farmers in my research. For example, I calculated the impact from my recent experiment. I found the total number of pounds of sweet potatoes produced in Georgia and then multiplied the Brix percentage I found in my experiment to the total number of pounds. I then multiplied this number by the pounds of added sugar and the cost of sugar per pound. Finally, I completed the calculation to learn by curing sweet potatoes, Georgia farmers could add a value of over $2.9 million. Being able to find practical applications of mathematics and science like this will be primary to my job as an agricultural engineer. Thank you for allowing me to share the details of my research SAE with you during this virtual interview and helping you get to better know Zachary Dahl.